Welcome everyone to the podcast of Gas Pathways, a new multimedia communication platform dedicated to innovation and technology in the natural gas industry. Joining me today is Martin Keighley, CEO of Carbonfree Chemicals, to discuss how his company is seeking new ways of utilizing carbon. Hi Martin, good to have you here.
Hi Joe, good to be here.
So to start off, let's talk about how your Skycycle and SkyMine technologies work. And in terms of climate change, what is their rationale?
So I think Joe, yes. So at Carbonfree, we've been working for, it's over 15 years now on carbon mineralization. And really the thinking being that, rather than just capturing CO2 and storing, putting it under the ground, the opportunity of actually on the surface mineralizing the CO2 into usable products, carbon negative chemicals, which can help the whole carbon value chain, and also doing that profitably is something that has a lot more attraction. It's a low value, low infrastructure cost way of dealing with CO2. And we've developed solutions which are able to go from mineralization, carbon capture utilization, and eventually, if necessary, at large scale into storage.
And what makes these products carbon negative?
So by the nature of the process, we make two processes. Our SkyMine makes baking soda, sodium bicarbonate, and our Skycycle, which is the product, the technology which we're now pushing forward, makes calcium carbonate, precipitated calcium carbonate. So by the nature of that, we take in calcium chloride, waste CO2, and the overall, when you do the life cycle analysis of a Skycycle process, is about negative about 0.8 tons of CO2 per ton of calcium carbonate made. And this is in comparison to traditional methods for making these mineral product chemicals, which are 2 to 3 tons of CO2. So the delta is actually very significant, nearly 4 tons of CO2 of saving to the planet. And you also then capture the CO2 from the industrial emission source.
And what are the applications of these products? What are their uses?
So in the case of PCC calcium carbonate, essentially it's the high purity form of calcium carbonate, the chemical form. So it goes in as fillers for plastics, papers, paints. Can be used in cleaning products like detergents, abrasive household cleaners. So there's a wide range of different chemical applications. It's a very large global market. And then when you go into the lower grades of these products, essentially you're making synthetic limestone. So you can go down into cements and aggregates and fillers into concrete building materials, etc. So a very wide range of different applications.
And could you take us through the company's story so far? How long have you been about? And where are you now in terms of research, in terms of pilot projects, and what lies ahead?
Yeah, in different forms, we've been around for over 15 years. Joe Jones, who was our original inventor, our CTO today, he had this vision that you could actually and spent a lot of time developing and working on the chemistry to find the right chemical components that would make the right minerals, and particularly doing it at a low energy. A lot of people believe that you couldn't do mineralization without having to put a huge amount of energy in, which made it didn't have any purpose then in terms of capturing CO2, because you spend more CO2 than you were capturing. In 2008, 2009, we got a DOE grant, which allowed us to build out the first of its kind SkyMine plant, making baking soda. And that plant we started commissioning in 2015, 2016. We operate here in San Antonio, Texas. It's the first of its kind commercial plant. And then over the last 12 months, we've been pivoting the business towards Skycycle, which is our much larger scale calcium-based technology. We do all our research at Southwest Research Institute in San Antonio. We have a large-scale demonstration plant, more than 10,000 ton a year capture plant, where we're completing and refining the engineering and producing sample PCC products. And then at the moment, we're currently in the final stage of engineering. We're partnering with Fluor, the large global engineering company,
Mm-hmm.
to final stage engineering, with our aim to place the first plant later next year, commissioning into 2023. So we're very, very close to the first commercialization of a 50,000 ton capture plant.
Okay, and who are can you talk about your investment partners? And you talk about moving, being on the verge of reaching commercialization. What needs to happen for you to get to that stage?
Yeah, so we have a great group of investors who've been with us for a long time. We're part of BP Ventures investment portfolio and part of BP's huge energy transition. We're part of Apollo, the large global investment group, and then we have 4 other major investors, 3 of whom are larger family office based, Fortistar, Carlberg, Bergenberg, and Husky, and then Braemar, which is a smaller sort of boutique energy transition fund. So they're the 6 principal investors, and we're just completing another large investment round, which will bring in another 3 significant investors. And that will allow us, for the question you're asking about, where that leads us to, that allows us then to drive through commercialization and build out the first plant, which we plan to complete the engineering on towards the end of this year and start going out for bids with a view to be able to then place and build that out through into 2023.
And these are potentially very interesting technologies to produce some carbon neutral industry products, but to really make a dent in emissions, it needs to be obviously scalable. What is the ultimate scalability of these technologies?
So you're right. What we're starting to find is stronger and stronger interest in reducing the chemical intensity of chemicals and mineral products. This has happened already quite a lot in the fuel space. We're seeing a lot of push down to sort of carbon intensity in fuels, but it's pretty nascent in terms of chemicals and products. So we're working with a number of major global companies who have an interest in their downstream B2C products having significantly lower, not just carbon neutral, but actually carbon negative products. So there's definitely a very large pull and a very large market, and we can do that profitably and actually get a much faster acceptance of carbon reduction without all of the infrastructure spending and time for large-scale storage projects. But as you say, we will be modularizing in 50,000 ton modules, so able to scaling by adding more modules. But the Skycycle technology is scalable up to million ton plus plants. With CCUS plays, because we're the full gamut from carbon capture, utilization, and storage. If we reach a point where there isn't a large-scale market for the calcium carbonate product, then we can evolve then into a storage solution, because what you've made is synthetic limestone essentially. So you've made a very, very stable chemical where the CO2 is locked up permanently, and you can then store that calcium carbonate. So you're not trying to deal with a gas or a liquefied gas and pumping it underground with all the uncertainties of whether the gas is going to stay there, whether it's going to leak out, because you've already got it through to a final stabilized solution in terms of calcium carbonate.
And how would you respond to the argument that CCUS is locking in the use of oil and gas for longer? Why should these industries be emitting in the first place? Why not simply switch them to renewables, to cleaner energies?
Well, we're providing a solution for all industrial emissions, not just into the oil and gas space. To some degree, the oil and gas producers will have to make their own transitions. We're finding major investors like ours, in terms of BP, are already investing in that energy transition. It allows for a smoother transition if we can reduce the CO2 from existing emitters. but also allows a transition. We're seeing companies like that looking to move, for instance, methane and natural gas into the hydrogen space, using sort of SMR, AMR sort of technologies to produce hydrogen. The challenge there is then you also emit large amounts of CO2. By adding a Skycycle to those hydrogen productions, you can end up with a renewable, low carbon, new energy source coming from the methane. So I think we're all in this game together in terms of a transition. So I don't necessarily see it as being good guys and bad guys. One of the benefits that we get from the CCUS solution from Skycycle is you are not then putting the CO2 back underground for things like enhanced oil recovery, etc., which certainly does promote the use of more fossil fuels. But in terms of cleaning, the reality is we're not going to turn those power and refinery facilities off straight away. So if we can start to capture the CO2 from those today, then when we continue to make a benefit and an additional improvement to the planet.
Okay, and could you give me an idea of the cost of these carbon negative products? I mean, how cheap can you produce them compared to more conventional ways of producing them?
Yeah, so we're very, very competitive because of the nature of the sort of modularized units for Skycycle. We're taking in the CO2 at no cost, and we're able to use low-cost salts and even waste materials to make those salts as a source of calcium. So we can be highly competitive just on a traditional apples to apples chemicals point of view, but of course we're making a significantly superior product because it's a carbon negative precipitated calcium carbonate, not a highly positive product that the existing chemicals are.
Okay, but they would still be more expensive than conventional ones on a par.
They can compete completely with existing products. Right. And actually, I think we believe further down the line there will be the potential to create premiums for these greener carbon negative chemicals. But as I say, the chemical industry is at pretty early stages of getting its head around carbon intensity of chemicals that aren't fuels. But the ability for the downstream products, be it a detergent, a cleaning product, we've been talking this morning to a company in a large cement and building products company in Thailand for making things like roofing tiles. Or we're working with BP, looking at areas where there are large demands for PCC into building products and ceramics. So there's a growing demand for these carbon negative products, which because companies want to put green labels on those the products they're selling to the consumers, sort of smart carbon products.
Is that to say, if they are competitive with the products which are produced via conventional means, is that to say that this technology could be scaled up without needing something like a carbon price, to kind of drive?
So certainly, great question. I mean, Skycycle plant can be profitable as a carbon chemical plant without carbon subsidy, carbon pricing. Obviously, I think in the last 18 months, we've seen a huge change in the mindset and the push for carbon, what I call sort of carbon monetization, be it a carbon tax or carbon credits. Both are the sort of sovereign ones or voluntary carbon credits, because we're seeing a lot of interest towards what we call engineered voluntary carbon credits as opposed to just the green, afforestation credits. So yeah, we can be profitable, but we will be more profitable, and then the business will be have much more risk reduced if there is significant carbon value. So we can play both ways, but we're not dependent on the carbon value like a lot of the carbon capture storage plays, where ultimately there is a net cost, and you have to pay for that capture, concentration, pipeline, storage, etc. And we're making a product which then goes through traditional infrastructure and is cost and market competitive with existing products.
And geographically across the world, do you see places which where these technologies are the most applicable?
Yeah, we're getting large interest across North America, Europe, and Asia. As I was on a call this morning with an Asian large producer, in fact in Thailand. We have another large potential investor coming from Korea. So we're getting a lot of interest. We've had a lot of interest from Japan. So we're getting a lot of interest across the spectrum geographically, and we're currently working on exactly where that first few locations of our plants will be.
Okay. Do you have any closing remarks?
No, it's great. I'm delighted. A lot of focus of carbon capture has been based around storage. It's great. I think over the last 6 months or so, we're starting to see a lot more interest in carbon capture utilization or carbon to value. So it's great to see that that's becoming much more of a talking situation, because the potential not just to capture CO2 but lock it up and then make these carbon negative products and chemicals, which will go down the whole value stream ultimately to the consumer, means we can have this big multiplier effect on the carbon that we actually capture.
Okay, well, thank you very much for joining us. And thank you for tuning in to the podcast of Gas Pathways, a new multimedia communication platform dedicated to innovation and technology in the natural gas industry. See you next time.